Okay, grade 12s. So we're looking at the second advanced lesson. Last week we covered the domain and range, as well as what's the value of x for which fx is greater than gx. So this particular lesson we're going to have a look at the parabola in particular, the inverse function of a parabola, as well as the restrictions that need to apply. So just in terms of context, I'm first going to explain it to you, and then we'll then have a look at the practical example. So when it comes to the parabola, you've got fx, right? So fx could, for example, be fx is equal to x squared. So if you were just to pump that into your calculator, you'll see that for fx equals x squared, you can do the table method over there if you'd like. And you'll see that if we do the table method, maybe what you can do is just do the table method for me quickly. So we're just going to have 5 points over there. So we've got x and y, -2, -1, 0, 1, and 2. So if everybody can at this stage just use your Casio calculators, you know how to do that. So you're going to basically go mode setup. Then you're going to go number 3 table. You've got fx equals x is your alpha close bracket, and that's to the power of 2, right? So we're going to go to the power of 2 for that one. That equals, we're going to start by -2 and we're going to end by 2, and my step is 1. So what you'll notice over there is that for -2, y is 4, for -1, y is 1, and then you've basically got for 0, you've got 0 there, and then you've got for 1, you've got 1, and you've got 4, right? So if you were to draw this, so that would be that would be 1, 2, 3, 4, and so you've got -2. At -2 you've got 4. At -1 you've got 1, and so on. So it's basically exactly the same on the side. At 1 you've got 1, and at 2 you've got 2 over there. Right, so the question is, if we now take that function and we swap it around, you'll notice that if we go f -1 x equals x squared, remember this is an inverse function, so you've got y is equal to x squared. We've got to swap that around, so that becomes x is equal to y squared. So you've got y squared equals x. If we just switch that around over there, and we then basically have to find the square root of x. So if that's the fx function, f -1 x, right, is equal to the square root of x. So if we were to do that same function over here now, you're going to basically see something very interesting. So let's just go through this as just a minor investigation. Let's just do a quick investigation. We need 1, 2, 3, 4. 1, 2, 3, 4. Yeah, I need 5 points over here. Okay. So what I'd like us to do now is the same thing. So you're going to have x and y. But what you technically have in this case, before I show you, I'd like you to just go through the normal procedure: -2, -1, 0, 1, 2. So you're going to do the same thing. You're going to say fx is equal to the square root of x. okay, the square root of x, and then we're starting here by -2 and we're ending by 2. Our step is 1. What you'll notice is by -2, if you look at your calculator, the by -2, by 0, by -1 there's an error. By 1 there's an error as well. Okay, so here you've got the 0, and here you've basically got, for 1 you've got 1, and by 2 you've got about 1,4. Okay, so what technically happens here is that theoretically, though this is theoretically, you've got 0, you've got 1 there. So theoretically what's happening is this over here. So this is how the function looks theoretically. So here you've got no value, but over here, the only reason why you've got this here is because the calculator has automatically assumed that nothing is happening on the side over here. Right? So the definition of a function is you've got that line method. So you cannot have, a function cannot basically have, if you draw a line, you cannot have two y values, then it's not regarded as a function. So the golden rule over here is I cannot have two, I cannot have this graph cutting there twice. So I can't have two y values for one x value. Then it's no longer a function. So what I need to do is I need to restrict this function in order for it to actually be a function. So how do I restrict it? I either need to restrict it by saying, for this to be a function, they're going to ask, the question they like asking is, what do I need to do to fx to make this a function? Okay, so if I want to restrict this so that it's a function, so let's just call this a restriction. So how do you restrict fx so that f minus 1x is a function? So the way we're going to restrict it is basically by saying, in terms of fx, x must either be less than 0 or x must be more than 0. So in other words, I'm finding out what is the y value of my, or the x value of my turning point, my axis of symmetry, and it's either going to be less than 0 or more than 0. Okay, I'm going to try to explain it on the next page. Okay, so the question that we're going to ask here is, number 1, how should we restrict fx so that f minus 1x is a function? And the second question they'll ask us is, how do you draw it? They'll ask you to draw it. So I said earlier on, the way we're going to do that is we either have to basically say, okay, we're going to get rid of this side of fx. Because if we get rid of that side of fx, it means that we're getting rid of this side of f minus 1x. Do you guys see that? So in other words, in answer to your first question, if you say that so for fx, we basically make it where x is basically only equal to less than 0. So if you make x less than 0, do you see that? You basically, that would be the answer to number 1. You've got to make x either less than 0 or you have to make x greater than 0. So if you make x less than 0, you're basically just left with the inner or the right hand side. So in this case here, if you made x less than 0 and you have to draw it, you're basically going to be left with this one over here. Okay, let me do fx in blue and f minus 1x in. So if we're going to do that, we'll see here that you've got, so here we're restricting, we're saying x is, if x is just less than 0, sorry, I apologize, x is less than 0, it's going to be over there, and if you're going to draw it, it's going to be over there. So that's basically the drawing. You see that? So that's the restriction. That's number one. And there's number two, the drawing. So if you're going to make the restriction where for this function, for fx, okay, this is for fx, of course, right? For fx, where you're going to make x greater than 0, basically the restriction is you're going to have, remember here you've got 0, here x is 0. So if you're making it greater than 0, it means that you're just starting by the 0. But the other function would basically then be this one over here. So it would basically be that. And that. Okay, so I hope that makes it clear to you guys. So the one aspect of it is where we're restricting it by saying x is less than 0, and the other one is where we're saying that x is greater than 0 for fx. They're not saying what's the restrictions you've got to place on f minus 1x. They're saying what are the restrictions you have to place on fx. Because remember, if we do this now, then if you look at this in green here is now f minus 1x. So if you have a look at it now, it is a function. Why is it a function? Because of the golden rule that it now basically only cuts once. Do you see that? Remember earlier on it cut twice. If you look at the green, it cut twice. So that can't be, it's not a function if it cuts for every one x value, you can't get two y values. Then it's not a function. Whereas in this case, because you've made that restriction, you know, that's basically how you're going to restrict it. So I didn't give you guys the steps for that, but you basically just have to find the axis of symmetry. So the axis of symmetry is basically the x value of your turning point. And remember that when we did our parabolas, if they gave it to you in the format of y equals ax squared plus bx plus c, your x value of your parabola was just the axis of symmetry was minus b over 2a. And if they gave it to you in that other format, in the format of y is equal to a x plus p squared plus q, remember your axis of symmetry in that case is basically going to be equal to minus p. So whatever p is, it's just the opposite sign. I do know that some schools or textbooks use the minus p, but I prefer this particular method myself. Okay. So so guys, that's basically how you restrict your particular parabola. You're restricting the original function. You're not restricting the inverse function. Okay guys, I realize it's a bit of a tricky section, so I want us to answer 4 questions, okay? In order to understand this particular section, the first question we have to ask ourselves is what is regarded as a function? So a function is basically regarded as it must have 2 x values for one y value. It could also have 1 x value for 1 y value. That's fine. But you cannot have 2 y values for 1 x value anywhere in the function. Then it no longer qualifies to be a function. So that's the first important question. The second important question is, how do we draw inverse functions? There's normally 2 steps to it. Step 1 is we're going to swap the x and the y around. Step 2 is we make y the subject of the formula. Obviously in grade 12, when it comes to our exponential functions, because x is an exponent, what tends to happen there is you have to use logs to help you with that particular process. But this particular lesson is focused specifically on the parabola. And the question here is, what happens when you do the inverse function of a parabola? Your fx becomes f minus 1x. So what tends to happen without having to do it on a calculator is that there's a rotation of 90 degrees in a clockwise direction. So you'll notice that your turning point is a point of interception, and you basically have a rotation from the one fx to f minus 1x. and if we draw it on the same set of axes, then that's basically how it looks. And that point of interception over there, that's basically your turning point over there. So if you understand these three questions, we can move over to the last question, is how does the restriction work, and why do we need to do the restriction? Okay guys, so now we're going to have a look quickly at how do we actually restrict the original parabola function. Remember, we said you have, when you're doing inverse functions, you've got fx and you've got f minus 1x, right? So remember we said that if I, for example, ask you to do y is equal to, or fx is equal to x squared, right? And then you must do f minus 1x for that particular function. The one way to restrict it is, if you look at the original function, I'm going to do both functions on the same set of axes. The first function is going to basically look like that over there. Okay. My original function of f minus 1x, I'll draw it in red for you guys, is going to look like that over there. Okay, so it's basically meeting at the turning point. So according to those questions that we asked earlier on, is this a function? As it is now, f minus 1x is not a function. Why? Because of the golden rule. The golden rule says I can't have two here, all across here. They have got one x value. So if here you've got, for example, x is equal to, let's make that 5. Okay. Over here, y is equal to, for example, I'm not saying it is, but for example, that could be 2. So this could be 5 and 2, and this could be 5 and minus 2. So that's impossible. It means that this isn't a function. So there's two ways for me to restrict this now. I can either say, these are my two options that I've got now, right? I can either say for fx, okay, I'm going to make x less than 0. Okay, so let's see what happens now. If I say for fx, I want to make x less than 0, this is what's going to happen. I'm going to, once again, I'm going to draw both functions. Let's use the same colors. I'm going to draw both functions. I'm going to draw fx and f prime x. Okay. So if I draw both functions now, but I'm saying it's where x is less than 0, it basically means that I'm only drawing this part over here. Do you guys see that? Now the corresponding, if we were to basically now just do the table method, right? You would notice that for f prime x, this is basically where my answer would be if you were to use the table method. So this is basically drawing that now. Similarly, the other option is I could say that for, so by the way, this over here would be fx, and this here would be f minus 1x, which is my inverse function, right? And then for fx, where x is greater than 0, when I draw that over there now, what I'm going to have is my original function was over here, because remember here x is 0, so that's 0, 1, 2, 3, etc. -1, -2. So for where x is greater than 0, I'm not drawing this on the left hand side, I'm only drawing the right hand side after my axis of symmetry, after my turning point. So what would happen is that if I wanted to draw the f minus 1x now, and you were to do that, it's basically this part of it now, the top part of that. Okay. So once again, f minus 1x, the red, is now a function. Why? Because I've restricted fx. So all I need to do is, if I want to make f minus 1x, not f prime x, sorry guys, f minus 1x, if I wanted to make f minus 1x, which is the inverse, a function, it means I need to find, there's two steps to follow, okay? There's two steps to follow. So step one is I need to find my axis of symmetry. So in other words, I need to find out what is the x value of my turning point, okay? X value of my turning point. So that's the first thing I need to do. And then the second thing that I need to do is I need to either make the axis of symmetry, the x value, greater than that or less than that. So for the original function, I now have to say that the x value is either greater than that axis of symmetry or x is less than the axis of symmetry. So that's basically the steps in simple terms, but we've obviously tried to help you guys understand why we get there. Okay, so that's basically this particular way in which we can restrict the original parabola function so that the inverse function can be regarded as a function.